Welcome back to Math Hacks. And if you're new to the channel, welcome. I'm Brett, and I am so glad that you're here. Today's tutorial is all about solving algebraic equations involving radicals. I'm going to walk you through a variety of examples of varying difficulties, and I'm going to show you a strategy that you can use to determine the order in which you solve any algebraic equation. Let's get started. For starters, we're going to begin with a really straightforward basic example. Here I have the square root of x is equal to 5, and I want to solve for x. So in order to get rid of this square root, I need to use the inverse operation, and that operation is squaring. So what I'm going to do here is square both sides. And when I do that, I can go ahead and cross out the square root and the squared. So that just leaves me with x equals, and then 5 squared is 25. Okay, now let's make it just a tiny bit harder. This time we have a cube root over x minus 1, and it's equal to 3. So once again, I want to get rid of the radical, and to do that, I'm going to use the inverse operation. So the inverse of a square root was a square. Now the inverse of a cube root will be a cube, or a power of 3. So I'm going to apply that to both sides. And we'll get, this will cancel out. And we'll have x minus 1 equals 3 cubed, which is 27. Now I have a basic equation to solve, and I'm going to add 1 to both sides. For this problem, I've introduced a multiplier in front of our square root, and it's important to note that whenever you're trying to solve an equation that involves radicals, you always want to just take care of anything that's outside of the radical first. So that means I want to get rid of this 10 to start with. Since it's being multiplied with the square root, I can go ahead and divide both sides by 10 to cancel it out. Now that there's nothing left on the outside of our radical, we can go ahead and use the inverse operation, which will be a square, and square both sides. Lastly, to solve for x, we just need to divide by 9. Now on this problem, I have both a multiplier and a number being subtracted on the outside of this radical. So I want to take care of those first. And if you get a little confused at where you should start in these type of problems, remember that solving is always just PEMDAS, or the order of operations, backwards. So if I'm doing PEMDAS backwards, that means I would take care of anything that's being added and subtracted first. Then I would take care of anything being multiplied or divided. And next I would take care of exponents. Note that our radical, since we can express that as a power of 1/2, falls under the exponent category. And then lastly, we would take care of anything in parentheses. And because this is the same as an exponent, our x plus 3 would be inside parentheses. So all you need to know is that the first thing you want to take care of in this sort of problem is to move anything that's being added or subtracted to the opposite side to start with. Now we can go ahead and take care of any multiplication or division. So I'm going to divide both sides by 2 to get rid of this multiplier of 2. Now all we have left on the left-hand side is the square root, so I can square both sides to undo the radical. And lastly, go ahead and subtract. Now, for the last problem of the day, we're going to look at how to solve a problem that has radicals on both sides. So this problem, we have the square root of 72 minus x equal to the square root of x over 5. Since I have nothing being added or subtracted or multiplied or divided on the outside of the radicals, the first thing I want to do is undo these square roots. So to do that, I'm going to square both sides. So this problem that looked really complicated really just boils down to 72 minus x is equal to x over 5. From there, we'll just use our normal solving techniques. Next, I'll add the 5x over. And lastly, divide both sides by 6. There are two super easy things you can do to support math hacks and keep more tutorials like this coming your way. One, if you haven't already, I would really appreciate it if you click that subscribe button and help our community grow. Two, give this video a big thumbs up to recommend it. Till next time, I'm Brett, and thank you so much for studying with me.